Okay, folks, so today we need to talk about temperatures, and temperatures have to be discussed. And the reason is because we in the United States love to use a unit that the rest of the world does not, and that is Fahrenheit. It seems like the majority of, non-third world countries use a unit for temperature that is not Fahrenheit, but we're stuck in our way and we're very stubborn and we're like, no, we're going to use Fahrenheit because we're the United States. So Fahrenheit causes us a problem. We never really talk about Fahrenheit in a laboratory environment. We always instead talk about another degree, and that degree is Celsius, and that's what the majority of the world uses. So as far as Fahrenheit goes, it's degree with a capital F. This is our Fahrenheit unit. And we use Fahrenheit. We're comfortable with Fahrenheit. We look at the temperature outside that's stated in Fahrenheit, but the rest of the world does not use that unit. However, we need, in order to talk about laboratory type of stuff and be in the scientific environment, we need to go with the flow and we need to go with the majority. And that means we need to get our mindset used to the Celsius temperature and not the Fahrenheit temperature. And that's what degree C is. So this degree C is all about Celsius. So Celsius. There is a third one, actually a fourth one too. The third one is going to be a capital K, and this is called Kelvin. And the scientific community really likes to go into the Kelvin temperature ranges, and I'll talk about why in just a second, but there is a third unit that's out there. So the rest of the world uses Celsius, we use Fahrenheit, but in particular, the scientific community likes to go to Kelvin whenever they can go to Kelvin for a reason. All right, so we're going to have to be able to feel comfortable converting one into another. And in the last video, I talked about what some of these equations will look like. So for instance, the very first equation that we had was this Fahrenheit equation. So it said degree F is equal to 1.8 times degrees Celsius plus 32, and this was in parentheses. So what this means is that if I had a Celsius read, maybe a temperature outside in Celsius, let's say that it's 30 degrees Celsius outside. I don't know what that is, right? As a United States person, you probably do not have any relationship of what 30 degrees Celsius means. We are used to Fahrenheit instead. Well, we can convert that Celsius into Fahrenheit using that equation. So we just plug the number into that equation in order to get it. So I'm going to take 1.8 and I'm going to multiply that by 30, and then it looks like I add 32 onto that value. So if it was 30 degrees Celsius outside, then in order for me to kind of maybe become more familiar with that measurement, I'm going to take 1.8 and I'm going to multiply by 30, and I hit enter. That gives me 54, which is super cold, but we're not quite done. We're going to add now 32 onto that number. So here we get an 86. So 86 degrees Fahrenheit is equivalent to 30 degrees Celsius. So that is how we use an equation like that. It's simple, two functions, you multiply and you add. So what you will always see is that Fahrenheit will be a bigger number every single time, corresponding to Celsius degree. So the Fahrenheit is going to be a bigger value. So that means if I'm trying to solve for Fahrenheit here, I need to make sure that that number is bigger than Celsius. And that's why we add, and that's why we multiply. It makes that number go bigger. So 1.8 times 30 plus 32. If it was 25 degrees Celsius, I'll take 1.8 times 25 plus 32. If it was 100 degrees Celsius, then I'll take 1.8 times 100 plus 32, and I get an answer for that. I don't want to be outside on that kind of temperature day, okay? All right, so that's how we convert If we've got Celsius, that's how we convert that into Fahrenheit. However, we can flip this around. Let's say that I've got a Fahrenheit temperature outside, and that Fahrenheit temperature, let's say that we made a measurement. We asked Google, hey, Google, what's the temperature? And it's going to say, well, right now it's 92 degrees Fahrenheit. What is that in degrees Celsius? Well, there's an equation for that as well. And we need to understand that Celsius goes smaller. It's a smaller number every time. So in order to solve for Celsius, I'm going to take my Fahrenheit number and I'm going to subtract 32 from it, and then I'm going to divide by 1.8, not multiply. So we're seeing a subtraction take place, not an addition, and we see a division take place, not a multiplication. So that means that number is going to go smaller. So now what I'll do is I'll take my Fahrenheit number, and my Fahrenheit number in this problem was 92, and I'm going to subtract 32 from it first. I do the top portion of that equation in one step, and then I hit enter. That gives me a 60, and then I'll divide by 1.8 after I hit enter. So order of operations is very important here. And then that degree Celsius is going to be 33.3 blah, 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 right? So Fahrenheit to Celsius, Celsius to Fahrenheit, we can flip back and forth between the two. And that's how we do that. So 92 degrees outside on a warm summer day is actually going to be 33 degrees Celsius in terms of the rest of the world, because that's the unit that they like to use. However, now what we're going to see in the scientific community is this temperature unit called Kelvin, and we abbreviate that with just a K. And Kelvin is this temperature unit that is needed for the scientific community because there are no negative values here. So if you lived in a very cold state in the United States, you could go negative Fahrenheit, right? I mean, we can get 0 degree Fahrenheit, and then you can easily hear someone say it's -5 outside, it's -10 outside, it's -12 outside. That is a issue that we have in a scientific community because we never really like negative numbers. Even according to temperatures, we do not like negative numbers. They can do funny things with our values if we're not careful. So we're like, okay, well, fine. Only a few people use Fahrenheit, and Fahrenheit can go negative. So what about the rest of the world? What about degrees Celsius? And the answer is, yeah, we can actually go negative on the degrees Celsius scale as well. So that still causes us the same type of problem, and that's why we don't really like to use Celsius in a laboratory environment either. And very often you will hear us, if we have to do calculations, right? If we are just reporting temperatures down, we'll report it in Celsius and we call it a day. There's nothing else that we need to do with it. But if we need to include that number in a calculation for whatever purpose, and this number could cause us a problem because it's negative, or it could be negative, then we use Kelvin instead in those calculations. So in order to get Kelvin, it's pretty simple. I take 273.15 and I add my degrees Celsius onto that number. And the reason that we add 273.15 is because Kelvin will stop at 0. 0 is the minimum number that we do on the Kelvin scale. So if I take the coldest Celsius that we can obtain, if I take that coldest value, that will be a negative number. And that negative number is 273.15. 273.15 negative Celsius is the coldest that we can get. So if I want a scale that does not have a negative number, then I'll add 273.15 onto that value. And 0 is the complete minimal. You cannot go lower than 0 on the Kelvin scale. That is the absolute lowest that you can go temperature-wise. No negatives at all, period. And that's good for calculations in the scientific community. So that's why we add 273.15. So for instance, if it was 30 degrees Celsius in the laboratory and I wanted to know what would that be in Kelvin, I'll take 273.15 and I'll add 30 to it. That's all that we have to do. Again, you can do that in your head probably, but if you needed a calculator, not a big deal. I'll take 273.15, well, sorry, 0.15, and then I'll add 30 degrees Celsius onto that value, and that gives me 303.15. So 303.15 is going to be the answer in terms of Kelvin. Notice with Kelvin, there is no zero or degree symbol here up in the top left-hand corner. That is degree Fahrenheit, degree Celsius, but this is not degree Kelvin. We actually do not use the degree symbol at all for Kelvin. So it's just straight up K. That's all that it is. So that is how we convert one temperature unit to the next. It's just a couple of equations that we need to know how to plug numbers in and how to solve for them. Notice though that if you do have Kelvin, or if you want Kelvin, you need degrees Celsius first. So that means if you're in the United States and you're measuring a temperature in Fahrenheit, you cannot directly go from Fahrenheit to Kelvin, or at least we're not going to. We're going to use these two equations that we've talked about. So you need to get Fahrenheit into Celsius first, and then when you get to Celsius, you can at that point go to Kelvin. But you need to go from Fahrenheit to Celsius in order to get that value, so you can substitute that value into the Kelvin equation. All right, so there's going to be a little bit of extra work if Fahrenheit is given and you're told to go straight to Kelvin. You can't do that in one step. You got to go to Celsius as the middle unit. All right. Okay, so that's a little bit about temperatures. Again, Fahrenheit, only a few countries in the world use it at this moment. The United States just so happens to be one of them. Fahrenheit is not used for the rest of the world, so Celsius is actually the most common temperature unit. And in terms of Celsius, it's still not good enough because we can still get negative values, and we do not want negative values in scientific calculations. So because of that, we can go into the unit of Kelvin, and that requires another conversion, and the scientific community uses that unit for that reason. One of the reasons, at least. All right. Okay, so good luck with all of the conversion problems. That's all that this one's going to be about. Just a kind of straight up temperature conversions, one to the next. What are the three major ones and why do we have them? These equations still work with negative numbers. I don't want you to be weirded out with that. So for instance, if we had a number of, I don't know, let's say negative 10 degrees Celsius, what is that in terms of Kelvin? Then you still substitute it in the equation like normal. You don't get weirded out by that negative number. So Kelvin is 273.15 plus, and then in this case, it's just a negative 10 instead of a positive number. So if you key that into your calculator, you'll see that your Kelvin here is going to be 263.15 because of that. So don't let them weird you out. The negatives are perfectly fine. You still use them as they're written in the equations without a problem. If this was negative 10 degrees Celsius and they wanted you to go to Fahrenheit with that, so keep in mind Fahrenheit should be a bigger number, right? So if you're going to solve for Fahrenheit, you're going to take 1.8 times the degree Celsius, and you do that kind of first, and you add 32. That ensures that the number goes bigger. You still use the negative number. This is going to be 1.8 times a negative 10, and then you're going to add 32 onto that value. All right, so here in the calculator, I'm going to put 1.8, and I'm going to multiply this by 10, and then I'm going to hit the negative button here to make that a negative 10. You've got the same thing on your calculator. It's not a big deal. Just push that negative before you type in the number on your calculator most of the time, and then you hit enter. You get a negative 18 here. You keep that negative 18. It's still negative 18. Nothing happens to the negative value, and then you add 32 onto that number, and that means that your degree here is going to be 14. So negative 10 degrees Celsius is going to be 14 degrees Fahrenheit. It's still a bigger number. You know, it started off being negative Celsius. 14's bigger than negative 10, so it still goes along with our reasoning, but you do keep those negatives. Do not let them weird you out about it if you see those in example problems. All right. Okay, so good luck with the worksheet. It's all about conversions with this lecture module. Again, if you've had another science course, if you've had, whether it's been in high school or on the college campus, maybe in middle school, they showed you some of these conversions, maybe not as much, but conversions maybe is something not completely new to you. If it is, no big deal. Hopefully these videos will get you through, but the majority of you probably have seen this before, and if so, good luck on it. This was just kind of tailoring up those, reviewing those to kind of make sure that your head is in the right place when you do the assignments. All right, so if you've got any questions, let me know. You know how to reach me.